Good evening, good evening, good evening, good evening. Uh, Welcome to my video on dividing monomials. That's what those things are called. Okay. So let's get through this video. Let's go through some things real quick just to get on. Now, if I multiply two fractions, say 3/3 and 5/7. So if I multiply two fractions, 3/3, 5/7 together, uh, the way we multiply fractions, we multiply straight across. We multiply the tops, multiply the bottoms. So in my numerator, I'm really doing 3 times 5. And in my denominator, I'm really doing 3 times 7, right? And this would actually give me 15 over 21. We all remember this. Now, one thing to take in consideration is if, in fact, we're going to reduce, all we do is we just go backwards, don't we? So from 15 over 21, we go backwards. We find we break up the numerator and we break up the denominator, and we can break that up to, oh, I don't know, 3 times 5 in the top and 3 times 7 in the bottom. Now, as we go across and we're still going backwards, this will be 3 over 3 times 5 over 7, right? So then notice here that 3 over 3 equals 1, so we can cross that out. And all we're left with is 5/7. So we can reduce 15 over 21 to 5/7. Understandable with just going backwards. So that's the whole idea of reducing. You're basically just backwards multiplying. So let's go through a couple more of these. Let's go through another one of these just so you guys can really see it. If in fact I'm reducing, say, 24 over 36. If I reduce that, I can go through the same process that I did here. So this same process right here would help me reduce my fraction. So reducing this, I can find a common factor in them, preferably the greatest common factor, and try to reduce that. So between 24 and 36, I know that 12 will be our greatest common factor, right? So it's up to us to find out, what do we multiply by 12 to get 24? That would be 2. What do we multiply by 12 to get 36? That would be 3. Now, here, up here, notice how in this part, I went all the way to separating the fractions and then crossing out crossing that one out to get 5/7. Here, I can actually skip that step and just cross out the 12 over 12 here. And reducing 24 over 36 will just give me 2/3. Easy enough, right? So we can actually use that kind of idea and do it with more complex terms. So one thing I'll show you is, say, for example, we're doing 2 to the 5th over 2 to the 3rd. Yep, back to those powers of 2's that we always use. And if, in fact, I'm doing this, I can break up 2 to the 5th to be how many 2's? 5. Add to the numerator. And in the denominator, how many 2's am I going to write? I'm going to write 3 2's. Now, the same way I crossed out that 12, I can cross out 2 2's, right? But wait a minute, I can cross out another set of 2's and another set of 2's, right? So all I'm left with is 2 times 2. Or all I'm left with is 2 times 2. Or another way to say it is 2 to the power of 2, right? So we've concluded in this actual problem that 2 to the 5th over 2 to the 3rd is going to give me 2 squared. It's looking familiar, right? So from here, is it safe to say that x to the 5th over x to the 3rd is going to give me x to the 2nd? Now, what we're getting at is a particular rule that we're actually going to use. What if I did x to the 6th over x to the 4th? Wouldn't that give me x to the 2nd? So now notice what we're doing here. Notice how we're actually getting that. Quicker way to do it is I'm using this 5 and this 3. The way that I get a 2 here is I just do 5 minus 3. Using the 6 and the 4, the quicker way I actually get a 2 right there is 6 minus 4. So it's safe to say that x to the a over x to the b equals x to the a minus b. This is one of our laws for exponents right here that we will use a lot. Love that highlighter. So that's our basic way of actually doing. So let's get a little bit more complex with it and talk about if in fact we're trying to reduce, in particular, certain polynomials. So if we're trying to reduce certain polynomials, sometimes we're going to use this fact. First things first, before we start actually reducing polynomials, let's talk about everybody's best friend. His name is GCF, and we all know what that stands for, right? Greatest common factor. So trying to find the GCF of a monomial goes into actually how we simplify and we divide monomials. Prime example. Let's choose two very, very simple monomials. So let's say 16xy, and let's go 18x. See? Very simple, right? So the first thing we want to do to actually do the GCF is we can actually figure this out by expanding both of these, or prime factorize, if that's a word, whatever. Anyway, the way that we can expand this is, 16 would be 2 times 2 times 2 times 2. We kind of know that because that's 2 to the 4th, right? And also you have an x there and you have a y. So that's expanded out. With 18x, we can expand that to be 2 times 3 times 3 times x. If you're wondering how am I getting those values right there, I mean, you can just take 16 and 18 off to the side somewhere, and you can prime factorize them to see what you actually get. And we have 4 and 4 here, and that's going to give us a 2, another 2. This right here is going to give us a 2 and another 2. This will give a 2 and a 9 and a 3 and a 3. And don't forget that 2. So notice how, well, let me draw a line here to separate it. So notice how I did this really quick. What this gives us. So that's how I got that prime factorization. And really with the xy, you just x times y, and the x just is there. So now the whole idea is to just find out, since you're looking for the greatest common factor, you're trying to look for all the factors that these two have in common. The two that they have in common, they have a 2 in common. And do they have any 3's in common? No. They do have an x in common, though. So they have an x in common. So altogether, what do they have in common? They have 2x. Cool. So the greatest common factor, and I got 17 minutes to finish this video. The greatest common factor between the two is 2x, right? So that's ideally how we find the greatest common factor of particular monomials. We can do another one just so, following the same idea. Let me split this off. Let's do another one just so we really, really get the idea. Let's talk about 21 x cubed y and 6 x squared y squared. If in fact I take these two and I wanted to find the greatest common factor of these, let's just split them up. If you prime factorize 21, you'll get 3 times 7, wouldn't you? And don't forget to expand out the x cubed y, which is 3 x's and 1 y. Here, with the 6, that prime factorizes to 3 times 2. times x times x, and then we have 2y's, right? So after that, it's up to you to find out what they have in common. They have a 3 in common. What else do they have in common? I see they have an x in common, and they have another x in common. Then they have a y in common. So we put all that together, and that will give us our GCF, or our greatest common factor. So we're talking the GCF equals 3 times x times x times y, right? So altogether, that gives us 3x squared y. That's what will give us our GCF. Easy enough, right? Now, the reason why we want to use our GCF, or the reason why we want to find our GCFs, is so we can start simplifying or dividing monomials. Hold on one second. Oh boy. Bear with me. This will not take long. Don't die on me yet. All right, now we're back. Good to go. All right, so now let me finish this word right here. So now we want to use all of that to simplify. So let's just start trying to simplify some polynomials to really give a good idea as what to do when we use all of those tools, all the tools that we just went over. So let's start with 25x squared y over 32xy cubed. Now, trying to simplify this right here, we want to basically reduce this to the lowest terms, which is what we mean by simplifying. So you already know how to simplify 24 over 32, but then you have to take in consideration the x squared y and the xy cubed. So for the most part, what we want to do is we want to break it up into its factors. Once you break it up into its factors, it's so much easier to do. You might want to take the greatest common factor between the two. I would take 8 times 3 in the top and 8 times 4 in the bottom. The reason why is that's the greatest common factor. If you went over here really quick and you did 24 and broke that up to what, 6, 4, 3, 2, 2, 2, and you broke that up, notice, and then, oh, well, actually, hold up really quick first. Do 32. That breaks up into 8 and 4, 4, 2. This is going to be 2, 2. And 2, 2, 2, 2. Now, if you're looking at what they have in common, notice what they have in common is 3 2's. That's where I get the 8 from, because 2 times 2 times 2 is going to be 8. So that's where I get as my, so the greatest common factor between 24 and 32 is 8. If in fact you need to do a factor tree to figure that out, please, by all means, if in fact you know off the top of your head the greatest common factor between 24 and 32, that's good too. Then after that, expand into the rest. The rest would be times x, since it's x squared times x, and since just a y, we'll put a y. And here, since it's an x, you take an x and y cubed, 3y's. Now, we can cancel out what we need to. All right, so the 8's cancel, the x's here cancel, and then one of the y's cancel, right? So then what you want to do is you want to write what you have left in the top, what you have left in the bottom. And what we have left in the top is 3x, right? 3 and an x. And in the denominator, what we have left in the bottom is 4 times y times y, which is 4y squared. So that's how we would actually simplify this monomial. I know that this can get a little tricky, so let's do one more just so we can really hammer this in. Say we do 35x cubed y z 6. Let's make it a little bit more complicated. And then we're going to do 56 x to the 5th y z. Now, to simplify this one right here, really doesn't really take much. You can expand this out. If in fact you did prime factorization for 35 and 56, you will see that in the top you're going to have 7 times 5 times x times x times x. Well, actually, you know what? I'm going to run out of room. So I don't want to run out of room. So let me write this problem a little bit over to the left and utilize the space that I have. Let's say 35, yeah, all the way over here to the left. X cubed y z to the 6 over 56 x to the 5th y z. Now we can do that. All right, back in the top, 7 times 5 was in the top. I'll use 7 times 5. And in the bottom, I'll use 7 times 8. Because the greatest common factor, if in fact you did prime factorization, greatest common factor between 35 and 56 would be 7. Now, just keep on expanding out. I have an x here. I have, well, 3 x's in the top, 1 y, and a whole bunch of z's. And in the bottom, I have 5 of these x's. I have 1 of those y's and a z. Now, it comes down to what cancels out now, right? So here we can cancel out the 7's. We can cancel out the x's, some more x's, some more x's. That looks about it for the x's we can cancel. We can cancel out a y. We also can cancel out just 1 z. So then it will help to rewrite every single thing that you have. What you have in the top is you have a 5, and you have 1, 2, 3, 4, 5 z's. So in the top you have 5. Well, you know what? Let's stretch it out so we can see it. So we have 5 times z times z times z. Yes, we got to do all of this just for the sake of understanding. So we have all of this in the numerator. And in the bottom, we have an 8 left. We have an x, another x, and that looks about it. So with all that being said, what we have left in the top is 5 z to the 5th, and in the bottom, 8x squared. So as you can see, all the tools that we're actually using to divide these monomials, or if in fact some of the directions will just say simplify. Hopefully this video was helpful to you. I hope you didn't fall asleep while you were watching it. Don't worry, they'll get a little bit more exciting, I promise. Peace.